In order to think about costs, we look at cost functions. And so a cost function is just something that says what the cost for a firm is in producing however much quantity they decide to produce. So here we have our total cost function. And on the horizontal axis, we have the quantity of cars, which we call Q. And on the vertical axis, we have the total cost of production or C of Q. And so for almost all firms, the total cost of production will be an upward sloping curve, right? The more you produce, the more it costs. That makes sense. And so you can think of the horizontal axis here is measured in units, and the vertical axis is measured in dollars or euros or whatever. Uh, and so our total cost function is something that most firms will have an idea about, right? But they might not know it exactly. But they'll have an idea of, okay, well, if we produce this much, it's going to cost us that much. If we produce this much, it's going to cost us that much. And so the total cost function is going to be very important, right? Because profit is obviously revenue, however much they sell, minus costs. Now, what we're often going to be interested in is not just the total cost, but the average cost. And so the average cost is just the total cost divided by quantity. And so here we have on the top graph the total cost curve. So this is just like what we had before. We've added some numbers now. And so you can see that it's increasing. And then the average cost is just the slope of the line from the origin to whichever point, right? Because that's just, remember, the slope is the rise divided by the run. And so the rise is just total cost. The run is quantity. So cost divided by quantity is average cost. Now, the average cost curve is going to look significantly different than the total cost curve, right? So one thing to note about this total cost curve, look at point F. That is uh, the fixed costs of producing. That gives us, that says, hey, we've got some costs, even though we're not producing any amount, right? We're producing zero, but we still have some costs. And so if we're thinking about cars, for example, you need to have a factory, you need to have machines, and you need to have, some workers who are setting everything up. And so you're going to have some level of fixed costs. And for a car manufacturer, those fixed costs are going to be quite high. If you think about fixed costs, for example, for an app developer, those are going to be much lower, right? They need to have a computer, they might need to have some programming software, but in general, the fixed costs will be much lower. So what does that mean? Well, that means that because we have these fixed costs at zero, as we start producing, the average cost is actually falling, right? And so we can see that at point A, the average cost us 80,000 to produce 20, and so 80,000 divided by 20 is 4,000, and so our average cost is 4. But at point B, now we're producing 40, and they don't actually tell us what the total cost is, but our average cost is 3,400, right? And that's the slope of that ray that's going from the origin to point B. And so our average cost has actually fallen from point A to point B, but point B is the minimum of our average cost in this example, right? And there will often be a minimum uh, average cost. And then at point D, for example, we're producing 60, and our average cost now is 3,600. So this is going to be really important for firms because what they care about is the difference between, if they're selling each of their units at the same price, which is generally assumed, then the average cost that they're producing at is going to be very important in terms of determining their profits. And so you can see from 0 until 40, this firm, this example, has increasing returns to scale. And from 40 and up, they have decreasing returns to scale. So this is often going to be an assumption that we make, that firms will have increasing returns to scale up to a certain point and then have decreasing returns to scale. Now, related to average cost, but actually a different concept, is this idea of marginal cost. Now, remember from chapter 3, the idea of marginal is that one extra, right? One extra unit, one extra hour, one extra whatever. In this case, marginal cost is the cost of producing one more unit, right? And so it is the slope of the total cost curve. And so if we were doing calculus, we would just take the derivative of the total cost curve if we knew it. But we can always just look at, all right, well, what is the cost of going from, say, 20 to 21, right? And so that's what this little circle is telling us, going from A, where we're producing 20 units at a cost of 80,000, and then we move up to 21. Now that extra cost is this delta C, which is 2,200. Whereas over here at point D, you can tell the total cost curve here is steeper, so we would expect the marginal cost to be larger. And in that case, increasing from 60 to 61 increases our cost by 4,600. And over here at point, I forget what we called it, B, I think, our change in cost is 3,400. And so in this example, our marginal cost increases with production. That's not always going to be the case. For example, it may be the case that firms learn by producing more, and so their marginal cost actually falls for a while. In this case, because the slope is positive of our total cost function, we are assuming that marginal cost is increasing. And now what we want to do is think about the relationship between average cost from the last slide and marginal cost. And one of the things that is always true is that as long as marginal cost is below average cost, so our marginal cost curve here in sort of purple, magenta maybe, is below the average cost here in blue, the average cost curve is going to be falling, right? So if the average cost is larger than the marginal cost, the average cost is decreasing. And that makes sense, right? Because if our average cost is 100, but it only costs us 40 to produce the next unit, then that's going to pull down the average cost, right? And there's going to be some point here at the minimum of our average cost where the two are equal, where average cost equals marginal cost. And then once marginal cost is larger than average cost, then that's going to start pulling up average cost. So average cost is going to start increasing. So if average cost is less than marginal cost, average cost is increasing. So whenever you draw a marginal cost and average cost curve, always make sure that the marginal cost curve cuts through the average cost right at the minimum, because that's always true by definition.